Okay, so we've already looked at y equals mx plus b. The other form is ax plus by plus c equals 0. It's called standard form. Now in standard form, all values are on the same side and x is positive. So we're on the positive x side. So if x is negative, that means we have to move them all to the other side or change all of the signs. There can be no fractions. And we need to reduce it. So what that means is if I had, so needs, I'll show you an example, to be reduced. Okay, so what that means is if I had something like this, 4x plus 2y plus 6 equals 0, all of those numbers can be divided by 2. This is like reducing a fraction. So we need to reduce this down to 2x plus y plus 3 equals 0. This is standard form. Whoa. Form. This is not. Okay? So convert the following into standard form. So the first thing we need to do when we're converting to standard form is make sure there's no fractions. Now in this case, there is not. Okay, now I'm gonna look at this first. It says, what are m and b? So if we're looking at the side there, it says, what are the values of m and b? Well, our slope here is -2, and our b value is 4. Now let's convert this. We need to have a positive x. So that means I need to move these numbers to this side. So I'm going to add 2x. I'm going to leave the y, and then I'm going to make the 4 minus 4. I've switched sides, so the sign changes. Now it's in ABC form. So the a is equal to 2. The b is the number in front of y, but in this case, if there's no number written, it's 1. And the c is the constant at the end, so it's -4. Now we've got the same question at the bottom there, just different equation. So our m is -2/3. Our b is 7. Now I need to, again, it's a negative x, so I need to move everything over. So I'm going to get 2/3x plus y minus 7 equals 0. I'm changing all the signs. Now I've got a fraction here though. So what I need to do is I actually need to multiply every term by 3 to get rid of that fraction. Okay, even the 0 on the other side is technically getting multiplied by 3. 3 times 2 is 6 in the first term we're looking at. So 3 times 2 is 6 divided by 3 is 2. So these two 3's go away. We have 2x plus 3y. 3 times y is 3y, minus 21 equals 3 times 0 is 0, so it doesn't change. Okay, so we've put all of the numbers or variables or letters onto the positive x side. We've cleared all our fractions, and if we check, that's all reduced. So now I can say that a is 2, b is 3, and c is -21. Now what you need to recognize for this is the b, the lowercase b, is not the same as the uppercase b because they're representing two different things. The lowercase b is the y-intercept. The uppercase b is the number in front of our y value in standard form. Okay, we'll do this one more time. So same kind of thing. So rearrange standard form to express it in y equals mx plus b. So what I'm going to do is I'm going to leave this part out and let you try it at home. And if you have any questions, you can ask me. But what we need to do first is we need to arrange it so we have y equals. So I'm going to leave it as 5y equals. Now the x is going to change to -x, and the 6 is going to change to +6. Now I need to divide both of those by 5. So we're going to have y equals negative, and that really says negative 1, but we just didn't write it. So I'm going to have negative 1 over 5x plus 6 over 5, because I need to divide all of the terms by 5. Okay, the next one. This one, we can actually move this y to the other side, and it makes things a little bit easier. So the next one's not in standard form because we could have reduced this, but that's okay. So this one, we have 8x minus 20 equals 4y. And now I can divide every term by 4. So we get 2x minus 5 equals y. And then I'm going to just rewrite that so that it looks nicer to y equals 2x minus 5. Okay, so first thing I did was I made sure the y was positive. So in the first case it was, so I moved the x and the 6 over and then divided everything by 5. So all 3 terms. The second case, I moved the y over because that made it positive, left the other 2 values on the other side, and divided by the number in front of y. All right, so last question. So celebration halls. So this is just giving us an example here. Okay, so the celebrations banquet hall uses the equation 15n minus c plus 700 equals 0 to determine the cost for the hall, where c is the cost in dollars and n is the number of people attending. Write it in slope-intercept form. So c equals mn plus b. So what we need to do is we need to rearrange it so the c is on the other side. So what we're going to get is 15n plus 750 equals c. I've moved the c, I've made it positive. Well, what I'm going to do there is I'm going to just make it look a little nicer and write it like this, because that's what we're used to seeing. Now, that's going to tell me the cost is going to go on the y value, and it's in dollars, and people, or attendees, is down here. Okay, and that's the number of people. Now it says identify the fixed and variable costs. Well, the fixed cost is the 750. Okay, that would be the cost for just renting the hall. The variable cost is the 15n. That's the number of people. Okay, it's $15 per person, and that can change depending on how many people are there. What's the cost of the rental if 150 people come to the banquet? Okay, we've got a soccer banquet. So what we're going to do is we're going to use our equation and we're going to sub in 150. Now we need to make sure we do BEDMAS. So we're going to do the multiplication first. So 15 times 150 plus 750. So we end up getting 3,000. Now it says graph this. So this is actually a really tough graph because what's happening here is we're not going up by a very large number every time. So what I'm going to do is I'm going to make my graph, and I'm going to show you why. I'm going to make it go up by 250 every box. So that means that every 2 boxes, it's going up by 500. So, or you can just think of it as every 2 boxes, it goes up by 500. Okay, so my cost is going up by that. I know my starting value is 750, so it's right there. Now, I kind of want to make it nice and easy. I want to make my graph look something like this. So what I've done here is I've actually drawn the graph in first. Now, I don't always recommend this. I think this is a little bit harder, but just because the number's so big, I'm saying, why don't we draw this in? And then we can kind of work from here on this. So this might actually be a little bit hard to do. So why don't we take that off? Let's go, well, we got up to 3,000 is 750. So what we need is to use $15 as kind of a guide. So we know every $15 is every person. So if I said like this was 10 people, that means we would have gone up $150. If this is 20 people, we would have gone up 150 and another 150. So $150 would get me to 900. Another 150 would get me to 1,050. Okay, so we could go up by tens each time if we wanted to. And our graph is going to look something like this. Okay, and now we can just do that and draw an arrow. Okay, so I've used my graph, I've counted by 15s, but rather than just going 1 here, 2, 3, 4, 5, and showing every point, I've counted by tens because we started at 750 and it would be really hard to show the whole graph otherwise. Probably most of the graphs we're going to look at won't be this difficult, especially the word equations, so I wouldn't get too concerned about that. If you make a scale that's relative to the slope of the graph, that's probably going to be the easiest way to show your graph. And here are some questions. We probably won't do the worksheet, so you don't have to worry about that.